Today we move to section 4.4, trigonometric equations, and we start off right away with solving for an angle in radian mode. And our very first question is a simple start, and we'll try to push forward the idea that you have to get to your happy place. It's just a nickname for a place where then the unit circle becomes very easy to use. So your very first equation to solve, again, it's called a trigonometric equation. You're trying to find what angles would make this work given the limitations that the angle must be between negative pi and positive pi, so negative 180 degrees and positive 180 degrees. In the equation, what you always have to do is a little bit of prep. Unlike in our previous course where it was right ready to go, the prep in this case would be to bring the 1 over, divide both sides by 2, and now you are ready to say what the angles are using the unit circle. This is what I call your happy place. When we go to the unit circle, all we're simply trying to remember is that cosine is x over r is always 1, so essentially it boils down to where is x positive a half. So first of all, I'm going to show you guys the different options, but then we'll really look at the bounds. This doesn't happen a lot, but sometimes they change the bounds instead of just 0 to 360 or 0 to 2 pi. So what would be your candidates? The very first one would be at 60 degrees. The x value is a half. As we go around, we might as well rule it out right away. 120 degrees will not work because it's a negative a half. 240 will also not work. 300 would. But here's where we have to be very careful. While we think that 60 degrees and 300 degrees would be our legitimate answers, the only one that we can actually write down is 60 degrees. And I'll change it to radians in just a moment. Why? Well, we cannot get bigger than 180 degrees. So the 300 would be bigger. But here is what we can do. We can actually work backwards. We can go this way, and so then instead of it being 300 degrees, if you work backwards, you could call this negative 60 degrees. And all that really matters is, what is in the x and y position? Well, in the x position, it is a positive a half. Therefore, we have our second angle that will work. Again, you don't get too many of these types of questions. You're typically staying between 0 and 360, 0 and 2 pi. But the odd time that it happens, we have to be able to think in terms of negative angles. So when we move to number 2 in the notes, what we will do is we'll again solve for our angle. And this is going to be more so what happens to you. So I'll just get right to it. We will usually be staying between 0 and 2 pi with all of our questions. Now, what you always have to remember is it's not going to be just set up straight where we are ready to solve, just like when you had cosine of theta equals 1/2 and it was right ready to go. There's many questions now at a higher level where you got to do a little bit of prep work to get it ready to use the unit circle. And then again, there comes the nickname that I've given it. It's your happy place. Once you get to that happy place, the unit circle is easy to use and you have your solutions. So in this very first question where we got a little bit more prep work to do, it just becomes a matter of analyzing, saying, what should I do? And it's going to be to collect your terms. If we have 3 signs on this side and I subtract them over, 5 signs minus 3 signs, we only have 2 signs. And then we have a plus 2 equals 1. I'm going to subtract this 2 over to the other side. I'm going to divide both sides by 2 now. It's like a reverse order of operations. And now I'm in my happy place. Now this looks very familiar for the unit circle. Sine is y over r, and it becomes as simple as looking at your unit circle and trying to say, where is the y value negative a half? Now in the previous example, what I had done was I had written down, well, where in degrees will we get a y value being negative a half? And the y values are negative a half at 210 and also at 330. What I often do, as you saw in the first bit of notes, the PDF version, so 210 and 330, is I often write down the degrees because that's how I think. Most people think in degrees. But then I remember we have to answer in radians. And then again, the unit circle is just so phenomenal. You look at 210, the radian version is 7 pi over 6. For 210, for 330, it is 11 pi over 6. And just in case you missed it, how do you know you're supposed to give your final answer in radians? Well, that goes back to the beginning stipulation, okay, the bounds. For letter B, we have a little bit more prep work to do again in a different way. This time we are given 3. Cosecant theta minus 6 is equal to 0. We are nowhere near our happy place, but it won't take long before we're there. In this case, we probably should just stick to our instincts, bring the 6 over, divide both sides by 3, and we're very, very close. I'm left with cosecant theta equals 2. I could put it 2 over 1. That might be a hint if you're running through your mind what you should probably do. I think what we need to do is get away from cosecant. Even though it's a very, very useful trig ratio, we don't really think clearly in terms of cosecant. But if I take its reciprocal, sine theta, and what you do to one side, do to the other, we'll do the reciprocal to the other side. We are back to our happy place. So where would sine be a half on the unit circle? That would be at 30 degrees and also 150 degrees. And then as always, we want to write them down in radians because that's the way the question was asking us to write them down, not in degrees. It's fine to write down the degrees, but make sure you get the radian measure down. And we have 5 pi over 6. The next 2 examples are going to be no surprise for anybody in my classes. We know what happens if you can't factor, and I think I've already given it away. The very first time you see questions like C and D, it can be a little bit intimidating, but once you get used to it and you calm down, factor like you know how, they're quite rewarding. And then something in chapter 5 comes up that's even better. So for our second last example, letter C, we have cosine squared minus cosine minus 2 equals 0. And you are very, very far away from your happy place. You could say you're quite unhappy because you're wondering, well, how am I going to solve this? How am I even going to use the unit circle? Here's what we are going to do. We are going to factor. That's supposed to be jumping off the page, kind of slapping you in the face saying, factor me, factor me. I know this is your first time ever factoring trig. You will get stronger and stronger at it. And just a reminder, if you have cosine squared, it really means cosine times cosine. We're used to it being written like this. In senior math, we write it as follows. You will get used to it and you'll realize it's maybe a more efficient way to write it. So here's how we begin. What would go in the first 2 spots? Cosine and cosine. If you imagine FOIL, first times first is cosine squared. And what we're going to do is just use an old sum and product. No fancy techniques needed. We need to simply move to the last 2 spots and say, what would multiply to negative 2 that would possibly add to a value of negative 1? Well, that will be positive 1 and negative 2. And now let's fully FOIL. First times first is cosine squared. The outer is minus 2 cosines. The inner is plus 1 cosine for a grand total of minus 1 cosine. And last times last is negative 2. It has worked. We have this equal to 0, just like we did in pre-calculus 20. And we swoopy swoop. I'm going to finish this side totally first. What I'm going to do is just one quick movement, and I'm at my happy place. I'm going to bring the 1 over. Cosine theta equals negative 1. We are now at our happy place. Cosine is x over r. R is always 1. All we're simply looking to do in the unit circle is find the x value where it's negative 1, and we've already found it. 180 degrees, or pi. And we have one of our answers. I'll just write the pi down. You can write the 180 if you want as well. Now this next swoop is going to be one that's quite rewarding in chapter 5. If we bring the 2 over and look at it, try to use the unit circle, nothing would happen. If you even tried to use your calculator and went second function cosine equals 2, you'd get an error. In chapter 5, we'll realize it. In this guy, it's an error. There are no solutions. For right now, let's just run with it. And once we finish chapter 5, it'll make perfect sense why no angles would actually work to give a cosine equal to a value of positive 2. Now for our final example, we are going to factor again. We're going to do a slightly different type of factoring, and this is going to feel like deja vu. We get so used to the reverse of FOIL, the factoring by sight, quadratic formula, decomposition, if you even remember decomposition, that we forget about the type of factoring that you learned before all of that. And that was just doing a GCF. So for your final example, we have sine squared theta minus sine theta equals 0. And we have to solve it. We have to say what angles would make it work. And again, final time today, we're nowhere near our happy place. We can't see what we're possibly supposed to do until we work with it, until we put it into a form that is easy to see. So what I want you guys to imagine and see is that there's two terms. And the common term that you could pull out as a GCF is going to be a sine. And what would you be left with? When you take a sine away here, you have just a single sine. When you take a sine away here, you're dividing it away. It's a -1. Many people miss that. And what should you really do right now to confirm it is do the distributive property in your head. Make sure that you understand why this is what we would have when we take out a GCF of sine. If we do the distributive property, swoop it in, sine times sine is sine squared, sine times -1 is sine. Now we're very close to our happy place. This one I'm going to do first, even though it looks kind of awkward. We have sine theta -1 is equal to 0. We bring over the value of 1. And right away, what we see is we're ready. If sine is y over r is always 1, we only have one spot. We have 90 degrees or pi over 2, and we're feeling pretty good. Now, you might have remembered me saying this phrase before. No one misses this one, but everyone and their dog forgets about this one. There are answers also associated. Where is sine of theta equal to 0? Sine is y over r, we know that. Where is the y value 0? Well, we actually have three places. We have 0 degrees, 180 degrees, and also 360 degrees, and I just wrote them down in the radian version. Now we have the complete solutions. We have 4. Now, it's just before we end, remember and remind ourselves, what did we just do? Any of these angles, 0, 180, 360, 90, could be put into this equation. You could type them into your calculator, and you will get a value of 0 when you hit equals. That is solving a trigonometric equation.